Carena has been present in the market for over 90 years. It is one of the leading companies specialising in industrial chimney construction, the fitting of heat-resistant lining, and boiler and industrial furnace renovation. It's impossible to list all our projects. The fact is that we operate on all continents in 20 different countries. One of the Carena Group units is headquartered in Poland, in Gliwice. Carena in Gliwice is among the leaders in chimney construction, especially using reinforced concrete. About 70% of the 300-metre and higher chimneys in Western Europe were built by our company. Using the example of a project for Polska Grupa Energetyczna Elektrownia Belchatow, Polish power group Belchatow power plant, we will show that we achieved something more. In this case, the engineers of Carena took up the challenge of building a cooling tower for a power unit of 858 megawatts. The construction of the cooling tower, pylons and supporting equipment. Groundworks were started in May 2007. The preparation of the ground for the foundations of the cooling tower required an exchange of soil down to 9 metres. Over 45,000 cubic metres of excavations were made. About 25,000 cubic metres of all-in aggregate and 9,000 cubic metres of dolomite and concrete aggregate were used. About 150 soil density tests were made during the preparation of the ground for the foundations. The circumferential foundations that will ultimately carry the weight of the whole construction have a diameter of 124 metres and are made in the shape of a ring with a width of 6.5 metres and a height of 1.4 metres. More than 500 tonnes of reinforcing steel and 3,500 cubic metres of Class C 30-37 waterproof concrete were used in the construction of the foundations. Construction of the underground conduits to carry the hot and cooled water was started in September 2007. A hot water pipe was constructed inside the tower, measuring 4.9 by 4.9 metres and 50 metres long. 220 tonnes of reinforcing steel and 1,500 cubic metres of waterproof concrete were used for its construction. Cooled water is returned via a reinforced concrete chute with a drop of 15 degrees. The cooling tower shell is supported by 80 columns, 64 by 74 centimetres, with a height of 11.6 metres. The geodesic pylons were arranged in a V-shape and then placed in position by crane. Approximately 180 tonnes of reinforcing steel and 500 cubic metres of Class C 35-45 waterproof concrete were used in the construction of the supports. Foundations 12.5 by 12.5 metres to a depth of 2 metres were constructed in the centre of the cooling tower. In the first phase of the project, these foundations were used to support a crane, which was the main means of transport of materials during the construction of the cooling tower. The construction of the cooling tower shell was launched in April 2008. It was constructed with the use of 50 independent mobile cradles. The hoisting mechanism of the cradles was driven by hydraulic servo motors. The internal diameter at the base of the shell is 109 metres. A total of about 100 people worked on its construction. 4 Polish and 3 British construction engineers supervised the works, along with quality and safety auditors, and foremen supervised their own groups. In the initial phase, the rate of shell construction was 4.5 metres per week. With the decrease in the diameter of the cooling tower, even as much as 9 metres per week was constructed. It should be noted here that one ring is 1.5 metres high, and considering the dimensions of the construction, that is equal to constructing 250 metres of 9-metre high reinforced concrete wall every week. 2 reinforced concrete pylons were constructed for the main boiler room using the climbing formwork method. The outer walls of the 2 153-metre towers are 50 centimetres thick and are the major carrying component. The interior of the pylons is divided into horizontal communication sections, staircase, elevator shafts, cable risers, installation risers, air duct, and technological and social rooms. The whole construction includes about 1,100 tonnes of reinforcing steel and 10,300 cubic metres of B30 class concrete. Now let us go back to the construction of the cooling tower. The cooling tower will have two tasks. Firstly, to cool water for the power unit installation, and secondly, to act as a chimney venting combustion gases after their cleaning in absorbers. Two holes were designed in the reinforced concrete shell at a height of about 40 metres for fitting the exhaust pipes for the combustion gases from the boiler. The exhaust pipes were made during the construction of the shell in order to minimise the time taken for the entire construction. They are made of chemically resistant resins and laminates and have a diameter of 7.6 metres. It is September 2008 and the tower is 120 metres high. The crane used to transport materials is 160 metres high. It's possible to reach the peak with an external lift which travels at a speed of 30 metres per minute. At the top, specialists from Carena reinforce and pour the concrete of more rings. Still, about 60 metres of the cooling tower remain to be built. After reaching a height of 150 metres, the crane was extended to its maximum height of over 210 metres. In order to preserve its stability, the crane was anchored to the shell with 32 steel cables at two different levels. Modern cooling towers are designed in the shape of a single-surface hyperboloid. This gives them the required rigidity even with such an impressive height and span. The shell of the reinforced concrete cooling tower is almost 1 metre thick at the base. With height, its thickness reduces to 20 centimetres. The entire surface is covered with convex vertical stripes in the shape of trapezoids, which direct the masses of air. Such a system causes them to flow around the shell and directs them upwards. Thus, the cooling tower deals with the pressure of the wind. In January 2009, despite the prevailing winter conditions, the peripheral stiffening ring was made on top of the cooling tower. It's a U-shaped construction with a width of 1.7 metres and a height of 1.6 metres. Its outer diameter is 74 metres. The ring serves to enhance the stability of the whole structure. The construction of the cooling tower shell used 1,600 tonnes of reinforcements and 11,000 cubic metres of concrete, which attained Class C 30-37 after 28 days from pouring and Class C 35-45 after 90 days. The shell was constructed by professionals from Carena continuously from the spring to the winter of 2008, our company thus constructing the highest cooling tower in Poland. Its height is 180 metres. As already mentioned, the cooling tower also functions to exhaust combustion gases. The exhaust pipes cannot have any intermediate points of support inside the structure. Therefore, the only internal support for the pipes is a centrally placed structure with a reinforced concrete slab located at a height of 34 metres. The second point of support is the shell. The pipes, weighing about 100 tonnes each, were raised by two wheeled cranes with a lifting capacity of 500 tonnes. The lifting operation was performed using special equipment. It was one of the more complex operations which, as you can see, was a complete success after a few hours of work. The pipe outlets are positioned centrally inside the cooling tower facing upwards. This enables the airflow to lift the combustion emissions out of the 180-metre cooling tower. The inner surface of the shell, from the level of the water distribution pipes to the apex, was covered with a protective layer against corrosion caused by water and combustion gases. Similar protection was made on the outer surface of the shell from its top down to 2/3 of its height. The water distribution system was also constructed by Carena. The supporting structure was designed and constructed as precast beams, columns and pipes. 220 columns, 1,336 beams and 28 different ducts were built into the cooling tower. About 3,500 cubic metres of concrete were used for the prefabrication of these elements. In a central location, we constructed a duct to carry water up from -7 to +11 metres. There, the water divides into 4 main ducts supplying different sections of the entire cooling system. A Approximately 7 kilometers of plastic pipes with diameters ranging from 250 to 500 millimeters are in place at the sprinkling level, where more than 5,500 sprinklers are fitted. The upper side of the cooling system is covered with a drift eliminator made of specially shaped tiles. The cooling filling, 1.8 meters thick, is underneath. The cubic capacity of the entire filling is 14,000 cubic meters. 8 10-meter high reinforced concrete wind baffles were constructed under the cooling system at floor level. Access to the top of the cooling tower is provided by a ladder with resting platforms built every 8 meters. The water distribution level can be reached thanks to a staircase on the south side and a ladder on the north side of the structure. The ladders and railings inside the cooling tower are made of polymer blends to ensure complete elimination of the risk of corrosion. External ladders and galleries, on the other hand, are made of galvanized steel and in the top part of acid-proof steel. This cooling tower built by us is so far the largest of its kind in Poland and the whole of Central and Eastern Europe. It will work with the largest and most modern power unit of the PGE Belchatow power plant. As you can see, the professional competence of the Carena engineers, backed with over 90 years of tradition and experience, make it possible for Carena to implement innovative, previously unheard of solutions in the Polish market. One could say that for investors, we're a partner who can meet the highest requirements.